Hi, thanks so much for joining me. I'm Matt Gracie. I'm really excited that you're here to find out more about wave cut platforms and understand this fascinating geological landform at a coastline. As you can see in the picture on this slide, what we're talking about is that long, sloping, rocky platform that forms in front of a cliff at a coastline. So in today's lesson, we're going to look at an image just like this one here that shows us that platform in front of the cliff. We're going to look at the steps that are required for this to form at any coastline. We'll review those steps. We will then talk about how you might actually remember those steps for the medium to long term. And then I bet you'll have questions. And let's take this further. And that's what we're going to do as we finish later on. So to start off with, what is the story? The story is we start with a cliff at a coastline. And that cliff over time is going to have erosion occur. That means that it moves backwards and leaves a platform in front of it. So you can see a cliff without a platform at Ballard Down, the south coast of England near the town of Swanage. And then you can see a cliff that does have a platform at Flamborough Head in northeastern England, just north of the Holderness coastline, which you might be aware of, a very rapidly eroding coastline. And the story is, how did it go from that one cliff to the one that has a platform? Well, in order to get there, before we start with the steps, there are two conditions that we must meet first. Number one, we need the right geology. We need firm geology. It means that cliff is going to hold upright and keep its shape throughout. That's what we can see on that lovely chalk cliff on the image. In the image next to it with soft clay, we get slumping, where the cliff moves in a rotational manner and looser sediments are applied onto the beach. And that will not form the wave cut platform. We need nice, resistant, firm geology that's going to hold its shape. The second thing we're going to need is a high energy coastline that is going to do erosion. If we had lovely, soft, lapping waves, there would not be erosion of the cliff. They would not be able to wear it away and cause it to retreat. We need that high energy waves, just like we can see in this image of storm waves here, that mean that we're going to see erosion of the cliff. So as we can see here, the erosion of the cliff happens at its base. So if my cliff is standing upright, it's the base. And it happens between the high water and low water marks, where the tide goes up and down every day. 2 low tides a day, 2 high tides a day, and all day the water goes up and down, eroding the cliff. There's in particular 2 types of erosion that are going to do plenty of damage to our cliff here. We've got hydraulic action, the force of that wave hitting down on the cliff, exposing cracks and weaknesses with great force. And we've also got erosion, all those rocks held in the cliff being thrown at the base of it. Abrasion with the rocks thrown, and hydraulic action, the force of the water. And as they continue to do that, the base of the cliff starts to take on this sort of C shape that is a notch, a wave cut notch, cut by waves at the base of the cliff. Now, over time, that notch is going to grow and retreat and get bigger and bigger, and it undercuts underneath the cliff. And over time, that undercut is going to mean that the cliff cannot hold its weight anymore, and it will collapse. And as my cliff starts to collapse, 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 it leaves behind it this wonderful big platform out in front. My cliff with a big platform out in front because it's collapsed successively over a long time, leaving the wave cut platform. Now, the wave cut platform, it can be really long, hundreds and hundreds of meters, but they'll always be very flat. They would never really exceed 5 degrees in gradient. They're a very, very flat landform. And they continue to grow until the top of it reaches that high water mark, because now the water's not able to erode anymore. So let's review. We've seen that we needed the right geology and a high energy coastline. And once that happens, we get erosion at the base of the cliff that causes that wave cut notch to form. The wave cut notch continues to grow and undercuts the cliff, and it can't hold its weight. So what we see is successive cliff collapses and the cliff receding away from the sea, moving away from the sea. And as it collapses and moves back, it leaves a wave-cut platform. I hope that that's helped you understand. I hope the visuals have meant you can see it, and I hope the diagrams have shown you can draw those diagrams for yourself very easily. But what can we do with this information? Here's 4 ideas of ways that you could take this information for revision, for recalling information, so that wave-cut platforms become part of your knowledge, not just something you've seen on a video, but something you really know. But I bet that we also have questions. So let's take this further. Here are 3 potential questions you may have asked. Well, we saw a cliff earlier with no wave-cut platform. Why does some cliffs not have them occur? You might also have asked, well, what's with all those weird shapes that happen on the wave-cut platform? They're not smooth, they're full of cracks and dents and pools. And you may well know that sea level changes over long periods of time and shorter periods of time. And so what happens to wave-cut platforms when that happens? So our first question, that was about, well, why does some cliffs not have wave-cut platforms? Well, I hope, having watched my video, you've got an idea now. The answer is one of the conditions hasn't been met. Maybe the geology is too resistant relative to the energy of this coastline, or maybe the energy is not enough. There's something there that means there's not erosion and undercutting happening, certainly not over a long period of time. And it's probably due to one of those conditions. The second question about all those weird shapes, what's with that? Well, rocks are full of joints, which are places where they crack and join different sort of parts of the rock formation, and cracks and different layers. And as the cliff retreats, the legacy of those is different weaknesses left in the platform. And as those high energy waves come in with hydraulic action, force of the water, abrasion, the rocks being thrown at it, they'll expose those cracks and mean that you get erosion along them and formation of different weird shapes along the wave-cut platform. Now, if we saw sea level rise, what would happen is the platform out in front of my cliff is going to get covered by water. The water's going to rise and cover it, but the cliff at the back might start to see more erosion because that high water mark has risen and I'm getting more erosion on the cliff. But in some parts of the world, we've seen something called isostatic readjustment, where land previously covered by glaciers has rebounded and risen up. And there are other reasons that sea level might fall as well, something you might want to investigate further. And when this happens, we get images like this one in California, where the old wave-cut platform is now a number of meters above the height of sea level because sea level has fallen. And this means it's now eroding fresh, a new cliff, which in fact is the front of the old wave-cut platform. And the old wave-cut platform is now left above a cliff, and it's called a marine terrace or a marine platform around the world. And it's a landform that we associate with relative drops in sea level. I really hope that's helped you answer some of your questions that you wanted to take further today. Thanks so much for being an interested geographer. Thank you for wanting to know more about the world around you. If you want to extend yourself and find out about more of the things we've talked about today, here are some videos you could access to help you grow your knowledge of the world around you. It's been a privilege. See you again soon.